Okay, so this is a stream. This certainly is a stream. But yeah, so I'm just gonna get right into it. Hello, hi everyone, hello VOD gang, and I've got some homework I need to do. So yeah. Yeah, so I have chemistry homework and I have math homework. So I just have a couple questions for my chemistry. It's not really too many. Like, chemistry class is a pain. Yeah, so I've already done the first couple questions, so I'm just gonna skip to number 7. Here we go. 7. Anyways, so cobalt chloride, COCl2 mixes with fluorine gas, and this makes cobalt fluoride and chlorine. So how many grams of cobalt chloride how many grams of cobalt chloride are required? I'm just writing it down for my homework. To produce 5.3 times 10 to the 35th molecules of chlorine. Alright, so first I'm just gonna make sure this thing is balanced. So there's 2 and 2. I have like a second layer just so I can just draw. So there's fluorine and fluorine. Okay, 2 fluorine, 2 cobalt. Okay, this is chlorine gas, so that means it's on its own. It's what's it called? Diatomic, so it always needs to have a 2. I copied down the problem wrong. But yeah, so oh right, I need to do that in the other layer. Here we go. Yeah, so this first one. So I need to go from molecules of chlorine to grams of cobalt. So I'm just gonna draw myself a little map in the map. So hold on, let me grab the color selector actually. Oh, let's use green. I don't know. Actually, I feel like blue would stick out a lot better. So mass A. Hold on, let me give myself some more space. So mass of A. So this is like called stoichiometry. So we go moles A, and then we go erase all this. So moles of A into what's it called? Molecules. Molecules of A, right? But then, if we want to go to B, so moles of B to molecules of B. We get another arrow. This goes. Oop, it's a horrible A. My A's are horrible anyways. So mass of B. We can also go to gases. So volume of A. Volume A. No, B. Here we go. So let me just grab this. Let's cut it, paste. Let's like rotate this. There we go. Let's make this the work layer. Get out of here. Questions. And then other. Alright, so Control A. So let's stoic map. Let's make that. Let's move the stoic map real quick. Stick it over here. There we go. So we need to go from yeah. So we need to go from cobalt chloride. So okay, so we need to go backwards from chlorine to cobalt chloride. So we start with molecules of chlorine. So Cl. No Spotify. Give me a sec. Give me a sec. Clicky click. Boom, clicky click. And we'll go with, I don't know this. I'll loop that for now. Wow, that's loud. There we go. Alright, we're looping this. We're looping this. Just gonna go forever. Anyways. So, let's go back over here. So, we go from chlorine gas. We have 5.3 times, let's make this a little bigger, times 10 to the 35th, right? Molecules. That's gonna be just go. I can't do like MOL because that's moles. Mol. I don't know. Molecules of chlorine. Can't draw straight lines on a tablet. There you go. Let's also move this map here. Stoic map. There we go, and we go back to the work layer. Let's make this all red, actually. Brushes. Ooh. Go like this. So we could go for brighter red. There we go. Actually, there. 5. Okay. I'm gonna erase this line actually, I don't like it. Here we go. I spent this entire time like formatting the screen. Here we go. So that's molecules of chlorine. 6.02 times 10 to the 24th, right? Well, let me check. Moles. Chemistry. 23rd. 23rd. It is the 23rd. So we get rid of this. Times 10 to the 23rd. Molecules of Cl2 is equal to 1 mole of Cl2. So that cancels out. And then, molecules, right? Okay, so like moles. Cl2 to moles of COCl2. How many? Okay, so everything is 1-to-1, so it's just gonna be. So everything is 1 mole, so just gonna fill in 1-to-1 for that, and then we go. What's it called? Okay, so we go from moles to grams. Moles to grams. How do I do that? Right. Okay, so the moles of chlorine cancel out. Bro's a mastermind? Hi, welcome to the stream. I'm cooking chemistry homework right now. Anyways, so we have a mole of cobalt chlorine. Boom, boom. With that. And then, okay, so cobalt. Let me pull over the periodic table.
That must have been some
I accidentally opened up another video tab. Anyways, I'm gonna close a lot of these. There we go. Now it's only the relevant tabs. So cobalt is 58.9. 58.9. I'll just go to the tens. So 58.9. Cl2. So 35.5 times 2. 35.5 times 2. I'm doing this on my calculator for me. So it's a 129.9. It's going to be 129.9 grams of ClC2. Okay, yeah, we're supposed to go grams of chlorine. Okay, there we go. So here, what we're going to do is we're just going to go across. So 5.3 times 10 to the 35th divided by 6.02 times 10 to the 23rd. And then we multiply that by 129.9. And that still doesn't look right. I get 1.14 times 10 to the 14th. 1.14 times 10 to the 14th. That doesn't look right. Because that would be like really, really heavy. Because we're going from molecules of A, right? Molecules of A. Okay, I'm gonna mark Cl2. That's an H. Cl2 equals A. CO Cl2 equals B. So go grams of B. So we're going from molecules to moles to moles to mass. This doesn't feel right. What did I do here? How many grams of cobalt chlorine? Cock. Don't point that on, man. But cock. Don't put. Oh yeah, don't forget to put my name. There we go. Alright, so okay, so I meant to go from cobalt chlorine. No, chlorine to cobalt chloride. So we start with okay, so the question says we start with 5.3 times 10 to the 35th molecules of chlorine. Does it make my head hurt? Like unironically. Oop, I accidentally killed the BBGM. Hold on, let me fix that. Here we go. yeah, so this is weird. Because like, okay, when I go from molecules of chlorine to moles of chlorine, like the difference is so huge, like 35 to 23. Like I still, okay, when you divide scientific numbers, you kind of like subtract the exponents, right? So like, even if I do this, like I still end up with like 14 or something. And then like, I also have to multiply it by 129.9 because I'm converting it back to grams. This is weird. I don't think there's anything I've missed, because like, yeah, I copied down the problem the problem correctly. It's like cobalt 2 chloride reacts with fluorine in a single replacement reaction to produce cobalt 2 fluoride and chlorine gas. Right? So it's gonna be cobalt chloride plus fluorine turns into cobalt fluoride plus chlorine. How many grams of cobalt chloride are required to produce however much chlorine? I think I'm doing this right by working backwards, because you... Because like, you're meant to go from... Thank God I don't have to take this next year. Like, this is normally fairly easy, it's just I don't think I've set this up properly. I don't know how to go backwards. Ooh, okay. Restart then? Because like, okay, I have my work here. Like, you start with molecules, right? You go from, okay, so we're going from molecules of chlorine, which I'm going to label as A. So you need to get the moles. You need to get the moles over grams of cobalt chlorine first. Like, yeah, okay, like the molar mass of cobalt chlorine is 129.9. Cause like cobalt is 58.9 plus 2 things of chlorine gives you 129 grams of cobalt chloride. So like molar grams of, you know, so like this is like the molar mass. So like, I do have the molar mass. It's just like the issue I'm seeing here is like 5.3 times 10 to the 30, like when you're converting from moles of chlorine. Wait a second. Yeah, no. Okay, so like we're going from molecules of chlorine to moles of chlorine, right? So we have the molecules here. Yeah, so we have the molecules here. The ratio is 1 to 1, so you just do the ratio is 1 to 1, so you just do the 129.9 times the amount of moles you need. So like, wait, because like, I sort of generally kind of understand how Stoic works. It's just like, I think I like lined this up incorrectly. Like, the ratio is 1 to 1, so you just do the 129.9 times the amount of moles you need. So like, the moles ends up on the bottom. Wait. Yeah, so, what's his name? The guy with the G, but I forget what his name is, like G's number or whatever. But like, they're like 6.02, around 6.02 times 10 to the 23rd molecules in a mole, right? So like, that's where I'm getting the second one. So like, if you were to like cancel out the molecules of chlorine to the molecules of chlorine, you would end up with this on the bottom. So like, you have 5.3 times 10 to the 35th molecules of chlorine, and like, you're converting it to moles, right? So like you just divide by you just divide by how many atoms are in molecules are in a mole. And then so like I do that division first, and then at the end here, like since the mole ratio is 1 to 1, I don't need to do anything. I do multiply by 129 at the end. It's just like here and here, right? Yeah, so like the answer I did get is 1.14 times 10 to the 14th grams. And that sounds really, really off. Cause like okay. Like, I really don't feel like you need this many grams. I mean, okay. Cause like it's just like 5.3 times 10 to the 35th molecules. Like 1.14 times 10 to the 14th grams is so much. Like that's like an incomprehensible amount, right? So like I feel like I'm like way, way off with my answer. Is the thing. Like I feel like I set it up all right. It's just like, hold on. It's like this is okay. So like stoic backwards. Like, so going back to the question, it's like how many grams of cobalt chloride are required to produce 5.3 times 10 to the 35 molecules of chlorine? Like the problem I'm having is like it gives us what we need, right? Like, not what we need. Like gives us the end result. Like we're supposed to go from cobalt chloride to chlorine. Like grams of cobalt chloride. So G of COCl2. Let's make that a little L, Cl2. And that turns into molecules of chlorine. You need to calculate the moles first before going to molecules, don't you? I think like the molar mass question mark. Cause like, wait, okay, so like, I've like just like this is the sort of like math that my teacher gave me, I guess. So like, what's it called? Like I do have the molar mass of cobalt chloride right here, which is 129.9. I don't think we need the molar mass of chlorine because we're going from molecules to moles, right? So molecules to moles. Hold on. Molecules to moles to moles to mass. So like we don't ever end up like needing to go to mass. I don't really generally like need this map. I'm just doing it just to make sure I like line things up properly. But like you never really go to like mass of chlorine. So I don't normally hit that. Cause like the problem here lies in that like there's like 10 to the 35th molecules of chlorine. And there's like times 10 to the 23rd in a mole. So like if I set it up the way I did, like going from molecules to moles, so like here we have like molecules of chlorine to moles of chlorine. Hold on. Let's just like do this like sort of step by step. So 5.3, hold on, parentheses 5.3 times 10 to the 35th, divided by 6.02. Hold on. Parentheses 6.02 times 10 to the 10 to the 23rd. We end up getting, what's it called? So if we just do just this, well, let's do this in a different color. We do this, and then we end up getting 8.8 times 10 to the 11th. So we have okay, so like already, so like moles of Cl2. So like this first part, we end up getting 8.8 times 10 to the 11th moles, which is, I honestly don't really have like a frame of reference in my head for like moles, but like when we also like, so like we convert to, so like this is like molecules of chlorine, we end up going to moles of chlorine. So, and then this switches it over to moles of cobalt chloride. And then this final conversion is grams. Oh, the first one is molecules? I was confused. Oh yeah, like I didn't like sort of like, I really don't know what to like do for molecules. I just put molk. Yeah, so like I set it up all properly. It's just like I end up with this like insane number. Like it's like, can you even imagine what 1.14 times 10 to the 14th grams would be like? Like grams, like a kilogram is already like 2.2 pounds, right? In like I'm just gonna work in like donuts. I'm gonna work in burgers. Equals 1 kg, right? About approximately. So like imagine 1 times 10 to the 14th kilograms, right? That's like 1, 2, 3, 4, 5. Let's like do this. So 1, 2, 3, comma 1, 2, 3. I apologize for my bad handwriting in advance. I'm a guy. Like I'm literally a guy. 3, 6, 9, 12. 1, 2, 3. That's a big ass number, right? Like that is such a big ass number. Like even like already 1 million. 1 million is huge. Like 1 million like 1 million kilos is huge, right? And like that's like 2 million. Hold on. Let me just like confirm that it's like kg to pounds. Yeah, it is 2.2. So yeah, like this would end up being like 2 million pounds. Give the initial question to ChatGPT and see if it gives you the same answer. That's actually kind of a mood, honestly. ChatGPT. Here we go. Do I need to? Oh, come on. Okay, I'll drag this off the screen on. So log in. Continue with Google. Do this. I'm just gonna make sure I don't like dox myself. Okay. For whatever. Okay, there we go. Right, ChatGPT. So cobalt chloride. Cobalt 2 chloride. Like, who's gonna stop me? Like, actually, who's gonna stop me? My teacher? No, my teacher's not gonna see me streaming my homework and be like, oh, this is my student and he used ChatGPT on my homework. That's not an issue. Like, in what world is that an issue? Yeah, so cobalt 2 chloride reacts with fluorine in a single replacement reaction to produce cobalt to cobalt 2 fluoride. Hold on, let me switch up the BGM just a little bit. There we go. Cobalt 2 fluoride. And to produce cobalt 2 fluoride and chloride gas. How many grams of cobalt 2 chloride are required to produce 5.3 times 10 to the 35th molecules of chlorine? Use stoichiometry to find the answer and answer in grams of cobalt to chloride. There we go. Oh, yo, okay. It's cooking. It's so cooking. What is this? Oh, it doesn't even give me an answer either, which is super nice. Okay. To find the amounts of cobalt to chloride, we can use Stoic and the balanced chemical equation. So, okay, so I actually do get the balanced chemical equation in the problem, and it actually does get the balanced equation, right? From the balanced equation, we see that 1 mole of cobalt chloride reacts with 1 mole, okay, Avogadro, that's what that guy's name is. So, like, 1 mole of any substance contains that. Okay, so I did get the first step right. So, like, this is like the dividing here. So it's the dividing, right? Now, since the balanced equation indicates a 1-to-1 ratio, the moles will be the same as the moles of chlorine. Next, we can use the molar mass. The molar mass is the sum of the atomic masses of its components. Okay, so that's what I did. So to do the values, finally multiply the moles. Okay, multiply the moles of. Okay, so this is just a recap of the summary of what I did. Okay, yeah, so this is basically exactly what I did. It's just not giving me an answer to it. It knows I'm trying to cheat on my home. Well, not cheat, but like it knows I'm trying to check my work. But all of my work is perfect. Cause like, so like there's a 1-to-1 ratio, which I have expressed here, right? I've expressed a 1-to-1. Just ask it again, specify you want the numbers low. Let's try that. I actually did ask it, like, use stoichiometry to find the answer, and answer in grams of cobalt-2 chloride. ChatGPT, what amount of cobalt? I don't know if this thing remembers things. Oh, what is this? Hi, welcome to stream. I'm doing my chemistry homework. Did you get from the problem? I provided the steps but didn't perform the actual calculation. Holy! Calculating this expression. This is the exact expression I put into my calculator, right? Because like, okay, hold on. I'm gonna like move this over to the side. That's a lot of reading, yeah. Like, I did just go over exactly the work that I get. But yes, my name is Abababa, but I don't know why my name's Abababa in here in the ChatGPT, but whatever, at least I'm not doxed. I don't understand. Well, that's chemistry for you. But yeah, so this first part, 5.3 times 10 to the 35th over 6.022. So like, I'm going only to like 6.02. But so like this is like this divided by this. So like since the mole ratio because of the mole ratio we don't do anything, and we multiply the ends by 129.9. So I guess the answer really is just 1.4 times 10 to the 14th. I'm trying to write. Okay, I have my packet in front of me. Like I'm just doing the work on my PC. I tried to write on my paper. Like I have my stuff on the screen, but I actually have my stuff on the paper. Like I have a packet in front of me, and I tried writing on my paper using my pen, like my digital pen. 1.14 times 10 to the 14th. My brother in Christ, you better be learning that, or I guess it doesn't matter if all the tests are online. Oh no, like I was just okay. Like I was like, okay, I actually did all of the work properly beforehand. Like I was just really confused. Yeah, I was just checking if I was doing it right. Because like I already set all of this up beforehand. Like, I mean, if you want to like watch the VOD, like you can hear me like rambling for like, how long has it been? Like 35 minutes? I've been here for like 20 minutes, just like sort of like setting things up and stuff. It's just like 1.14 times 10 to the 14th grams is huge. Because like, that's like 1,000,000 kilos. I mean, no, not 1,000,000. That's like this many kilos. And this many kilos is bigger than 1,000,000 kilos. And 1,000,000 kilos is like 2,000,000 pounds. Like, surely, like, 5.3 times 10 to the 35th molecules of chlorine. I mean, I guess, like, it's probably, okay, like, I'm not going to draw out all the zeros, but I guess it might be in the right ballpark. But I'm gonna go with that answer, honestly. I'm also gonna, like, that doesn't sound right. Exactly. Like, I guess the reason why, like, this may probably be right is because, like, 5.3 times 10 to the 35th is huge compared to Avogadro's number, you know? It's like, I'm just gonna roll with this, honestly. Our teacher doesn't exactly check answers. I just want to make sure I understand this stuff for the tests. So 5.3 times 10 to the 35th molecules of Cl2 times 1 mole Cl2. I'm just copying this down on my paper. Oop. Me who barely understands exponents. Like, okay, like, when it comes to, like, scientific notation, it's honestly, like, fairly simple. Times 10 to the 23rd basically just means, like, you add 23 zeros. So if I have, like, 3 times 10 to the 4th, this is just 3,000. 30,000 because there's 4 zeros. Oh, yeah, but I'm just saying it for the sake of stream. Why not? But yeah, so I guess we use all of the chlorine in the entire planet to make... Wait, we use all... I said barely understands, which means... oh, okay, yeah. My bad, man. Yeah. But yeah, like, I'm just gonna go with this, honestly. It works. 6.02 times 10 to the 23rd. Cl2. And then times 129.9 grams of cobalt chlorine. One word Google. I mean, yeah, but like, for the content, I guess. I'm just yapping. Anyways. Yeah, so that's the first problem. Okay, the rest of them should go by pretty fast, because, like, I don't think I'm gonna, like, double check all my answers. I'm just gonna go. So, like, I'm going to move on. Yeah. So, questions, black. Anyways, so we have C2H4. Okay, so we have a combustion reaction here. Boom, boom, boom. CO2 plus H2O. Okay. Anyways, let's actually move this O here. There we go. Close enough. Alright, let's make sure this is balanced first. So 2. We need 2 of that. Okay, so we're chilling in carbon. Okay, so we need double that. So that's 4, 5, 6, 3. Okay, so that's the equation balanced. How many liters of water vapor can be formed if 1.25 moles of C2H4 gas are consumed? Okay, so thank God we're starting with the reactants and going into the products. It's like that. So it's gonna be a water vapor because it's combustion, so gas. So we're gonna be going from okay, so we're getting moles of, okay, so we're starting in moles, which is nice. So we get moles of A, and we need volume of B. Okay. So this one's fairly simple. So like moles, what's it called? Okay, so we have 1.25 moles of C2. Hold on, let's do this all in a different color. Go back to work. Boom, boom. Okay. So we have 1.25 times, no, moles of C2H4. And the mole ratio from, so there's So the mole ratio is just 1 mole C2H4. Let me rotate my tablet a little bit. There we go. There we go. H4. No, I'm not gonna be like slanting downwards. Is 2 moles. Okay, so we're going to water. It's gonna be 2 moles. And then 1 mole of water. H2O. 22.4 liters of that. Okay, so it's gonna be 1.25 times 2 times 22.4, and that gets us 56. 56 liters of water. Vapor. So I'm just going to copy that down. C2H4 times 2 moles H2O, 1 mole C2H4 times 22.4 liters of H2O over 1 mole of H2O. Okay, there you go. All right, so for the next questions, I'm just gonna put up the I'm just gonna put up the equation. Yeah, I'm just gonna put up the equation and then just like simplified questions, I guess. All right, so it's not gonna hurt me to do this all in one layer. Let's go ahead and shrink this. There we go. Alright, so we have that. So we have another equation. It's strontium chloride plus hydrogen sulfate turns into... Hold on, let's give myself a little space just in case I need to balance. H2SO4 turns into HCl, hydrogen chloride plus strontium sulfate. Strontium. Where's my periodic table? Oh, here it is. Okay. Strontium. Strontium has a charge of 2, right? Am I being dumb? Yeah, so strontium has a charge of 2. Because, like, it's an alkali earth metal, which means it has a charge of 2. So would this not be... Like, my homework said... Like, my homework gives me the problem. Like, it should be this, right? Because, like, it's like this for the chlorine. That's... Oh, no, it's because... sulfate also has a charge of 2, yeah. Hold on, let me just, like, absolutely double check. Charge of sulfate. Okay, yeah, so sulfate also has a -2 charge, so we're chilling. Okay. I am not being stupid. So... what's it called? BO53, BOI 92, 92 is down here. BOIU. Wait, that's like BOIU. Okay, 53 is I. 92 is U. Is it a D's nuts joke? I mean, no shot it is, but like... Gallium... Zinc. BOIUGAZN. 5853. 58. Wait, 39. Did I hit 39 right? Oh, 3139. Oh. Oh shoot, what the hell did I do? Oh, there we go. Actually, no, that's not useful because I don't get access to the docs. I've been debated. I could smell it a mile away. Right, what was I doing? Right, homework. What mass of strontium chloride? What is the mass of strontium chloride that reacts with 300 grams of H2SO4? Huh? Okay, I'm gonna go ahead and write this. What is the mass of SrCl2 that reacts with 300 grams of H2SO4? I actually don't remember going over something like this. Are the rest of the questions like this? Not really. Yeah, so I guess I'm gonna have to sort of review percent yields and stuff. How do I do this? What is the mass of strontium chloride that reacts with 300 grams of... Ooh, I don't think I was actually taking notes. Either I was not taking notes or like, I just don't remember this part. Oh, this is weird. How did I even post this question to Google? Oh boy, molar math? Yeah, we got stoichiometry. So like this is actually like my only, really my only homework here. Like, I also do have a pre-calc test tomorrow, but like, I'm chilling. I think I'm gonna come back to this, and if I mean, how many moles is 300 grams? I mean, the question is like, if we have 300 grams of hydrogen sulfate, how much strontium chloride reacts with it? Oh, calculate how many moles of strontium chloride. Oh, wait a sec. So like, if I set up the question, if I set up the equation, like, if I set this up like H2SO4, so like, this is like something I could do. Yeah, so like, if we have, okay, what do we have? Okay, we have 300 grams. Well, you could chat GPT if you really wanted to. I mean, I actually did chat GPT for this question over here, but just to check my work, because like I got a really weird number. Like, I'm gonna see if I can tackle this myself. Yeah, so I think Did I balance this yet? I don't think I did. So this is 2, 2, 2. Wait, yeah, 2, 2. 1 strontium. Okay, yeah. So this is just okay. Just throwing in a 2, I think this is balanced. This is balanced, yeah. So if I go like this, so if I have 300 grams, my brain hurt. Bye bye. See you, man. But yeah. So okay. If we go for so if we go to like the moles, right? So grams of H2SO4. Moles of H2SO4. Okay, so okay, so the molar mass is so like I'm just gonna treat hydrogen as like 1. So like it's gonna be like 1 plus 1 plus I know oxygen is 15.9 times 4. So that just leaves sulfur. Yeah, chemistry isn't honestly really that bad. I just find it's just like a slightly annoying class. Okay, so sulfur is... I'll treat it as 32.1. So 32.1. 1 plus 1 plus 15.9 times 4 plus 32.1. So it gives me 97.7. 97.7. And then the mole ratio. Do I need to bother with the mole ratio? No, I'm not. I'm not going to hydrogen chloride. So it's just going to be moles to moles. Mole ratio, H2SO4. Yeah, moles. Where am I going? Strontium chloride, yeah. Times, and then we go mole SrCl2, and then we go grams of SrCl2, like molar mass. So, okay, I literally just checked sulfur. Sulfur was, what was sulfur? 32.1 plus whatever chlorine is. It's like 35, right? Yeah, 35.5 times 2. That's like, what, 71? 35.5 times 2. 71 plus 32.1. So we get 103.1. Yeah, so we go 300 divided by 97.7 times 103.1. And I get 316.6. Okay, we're actually cooking. We're actually hella cooking. Alright, so we get 316. Actually, we'll just drop it at 316. I'm a genius. Okay. 316 grams of strontium chloride. Okay, like that seems kind of in the ballpark because like we have like 300 grams. So I'm just gonna record this on my packet. It's like 300 grams of H2SO4 times 1 mole of H2SO4 over 97.7 grams. Blah, 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 blah. Moles SrCl2, moles of H2SO4. Blah, 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 blah. 103.1 GSrCl2, moles of SrCl2. And this all gets me 316 grams of strontium chloride. If only normal Alistair would solve all of my problems. If only. Alright, that's the second. That's the first half of the problem. But yes, like we're doing stoichiometry and stuff in chemistry right now. Just like mole stuff. And this honestly really isn't bad if you just like set things up properly. Like, you just have to know how to set up the, like, you just have to know how to like line everything up and just multiply through. So that's gonna be the first half of the question. So the second half, or just 10. What would the percent yield be if 200 grams of HCl was produced. Okay, so am I supposed to do this entire thing but with just like do I just like start with HCl and then do the stuff? I think that's what I'm meant to be doing here. Cause like, so like when it goes to like, comes to like converting stuff, I don't exactly understand in my brain like physically how this like actually works out. Well, I think what I'm meant to be doing is going from hydrogen chloride into strontium sulfate, I think. Alright, so I'm gonna change up the BGM again. You know what? Surely this won't kill me. There we go. There we go. And let's loop this for now. No! Okay, there we go. Let's loop that for now. But yeah, so like if anyone's wondering what I'm using for the BGM, I'm just using like VTuber covers, song covers and stuff because I'm really, really scared of classical music right now. Anyways, right. So, if we have 200 grams of hydrogen chloride, right? Well, let's use a different color just so, I don't know. Ooh, okay. 200 grams of... I actually have no clue how loud the BGM is. I'm just gonna turn it down just a little bit. Just a little bit. Here we go. Okay. Okay, I think that's good. I'm comfortable with that. Okay. Okay, so go hydrogen chloride. Grams to moles. So grams of hydrogen chloride. That kind of pisses me off. That's okay. This is whatever. Big C. To moles of hydrogen chloride. So hydrogen chloride 1 plus. Okay, chlorine is like 35.5. Yeah, it's a 35.5. So 36.5. Like hydrogen is like functionally 1. So we do that. So 2 moles of hydrogen chloride equals 1 mole of hydrogen sulfate, right? Yeah, we're going from... What would the percent yield be? Okay. Okay, so percent yield, hold on. Percent yield is like actual over theoretical times 100. So our actual is like 200. But what would a theoretical hydrogen chloride be? Wait a second. Am I supposed to... Okay, I think... Okay, so one of two things. Either I go from... Because like, I'm given a number of hydrogen chloride. So either I go from hydrogen chloride to... hydrogen chloride to hydrogen sulfate, right? It's like what I'm doing here. Just gonna like finish this up. Moles of H2SO4, 103.1 grams of H2SO4. Oh, SO4. I think. Yeah, so it might be this. But like, I'm also thinking it may also be go from this to that. But the problem is like they give us like hydrogen chlorine. So like I'm gonna go ahead and just like run this through, right? I'm gonna run this through, and I'm gonna see if I like the answer that comes out, and if not, I'll try the other one. The other one makes less sense, but like it's also an option that could possibly be something if I don't like what I get out of this. Okay, so hold on. Okay, I'm like doing Bren Thinky Think. Okay, Thinky Think. Okay, so 200 divided by 36.5 divided by 2 times 103.1. That gives me 282. Okay. That gives me 282. .282 grams, right? Okay, so I'd get 282. So like I think I'm just gonna work with that, 282. 200 divided by 282. I'm just gonna go with 70.9% yield. 70.9% yield. That's probably fine. That's probably fine. Imagine if I made a little. Imagine if like I made a little video for the channel on how stoichiometry works. I don't think anyone would watch it, but like it'd be kind of funny. It'd be kind of funny. All right. Okay, so that's that. 1, 2, 3, 4, 5, 6 more questions. Here we go. Make this big. There we go. Just gonna do erase. Actually, hold on. Let's bring all that back and just shrink it. So we go like this, and go like this, and we shrink. There we go. Okay, so let's start with the question. Oh boy. Iron 3. So, iron 3 chloride. Oh, it doesn't give me the, it doesn't give me the equation. That's probably fine though. Iron 3 chloride. Iron 3 chloride hexahydride. I think. Plus calcium chromate. For produce iron 3 chromate precipitate. I don't even know what that is. So, if this reaction is started with 5 grams of each reactant, what is the limiting reactant? Okay, so I'm gonna have to look up what the hell a precipitate is. Precipitate. Wait. Oh, it's just iron chromate. Oh. Wait. Huh? How does this even work? What? Okay, so okay, precipitate just means like it's like extra goofy stuff. So like you get iron chromate, CrO4 3, iron 3 chromate plus whatever the hell was left over. Other shit. Stuff. Okay, so how do I do this? Okay, I think what I'm meant to do is like convert both. Like we have like 5 grams of both, so we convert them into iron chromate. I don't think we need to know how much chromate we have, iron chromate we have, because we can just like find that. So what I think I'm gonna do is I'm going to sort of like convert both into like iron chromate and like whichever is the least. Okay, so okay, that makes a lot more sense. Okay, here we go. We cook. So we go FeCl3H6. I'm just gonna abbreviate all of this as like a star, I guess. Because I do not want to write this a billion times. Okay, maybe not a star. I'll do a triangle, I guess. So if we have 5 grams of this, and then 5 grams of calcium chromate. I'll just make the chromate a square. I don't know. Oh, we go. Okay, so 5 grams of the chromate. No. Okay, 5 grams of the iron stuff. So we go grams of that stuff to moles of that stuff. Okay, so to molar mass is going to be iron. Okay, so this is functionally 6. Chlorine is 35.5. I think iron is like 58-ish. What is iron? Where is it? Fe. Am I being dumb? Okay, it is 55.8. There we go. So 55.8 plus 35.5 times 3 plus 6 gives me 168.3. Okay, so 168.3 grams to moles. Is this balanced? I don't even know if this is balanced. Like, I don't... Because, like, 1, 1, 1, 1, 12... I'll be fine. It's whatever. Okay, so moles. So I think it's just going to be 1-to-1. And let's make this iron chromate like an upside down triangle, I guess. So we go moles of that, 2 grams of that. Chromine. Chromates, chromide, chromium. Okay, so 51.9. So 51.9, 55.8 plus 51.9 times 3 plus 15.9 times 16 gives me a hefty 146. Wait, no, 465.9. If we do the same thing here. So this is going to be calcium. What is calcium? Calcium is just flat 40. Yeah, flat 40. 15.9, and then chromium is that. So 40 plus 51.9 times 2 plus 15.9 times 8 is 21 flat. 271 flat. 2 moles of square moles of square, 2 moles of upside down triangle. It's gonna assume it's 1-to-1 as well. 465.9 grams moles to Dorito chips. Okay, so that's those two lined up. Let's see. Okay. So if I just plug these in, whichever one is the lesser one is the one that you have to pay. So 5 divided by 168.3. 5 divided by 168.3. Times 465.9. 13.84. Okay, let's grab this and move this actually. And then we go like this. So it's going to be 5 divided by 271 times 465.9, 8.59. So this means that whatever square, okay, so this was triangle, this was square, and this was Dorito chip. So the calcium chromate, the CaCrO4 is the limiting reactant. So I'm just gonna copy these down on my paper. 1 mole. Uh, 168.3 grams times 1 mole of thingy, 1 mole of thingy, times 465.9 of thingy over moles of thingy. Times that. Don't mind me just writing all this down. Moles of Dorito chips. For 65.9. Yeah. What did I get? 13.84. 13.84. 8.59. Okay. How many grams of iron 3 chromate could theoretically be produced? And that's going to be 8.59. Okay. So that's 2 more questions down. I just have 4 more. Okay, 1 problem left. 1 problem, what? Like problem, but 1 set of problems left. There are questions related to the same thing, so it might as well be a 4-parter. So, we have 4NH3 plus 5O2 stored to 4NO. It's nice because this is like balanced already. 6H2O. Okay. So that's the reaction. So we have 3.25 grams of that. And we have 3.5 grams of that. Let's see. What reactant is the limiting reagent? So we're gonna have to do all this, like write down all this again. I have so much time, dude. I have so much time. Okay. What do I do here? What am I doing? Right, okay. So 3.25 grams of NH3. That is something I'm fine writing down. So grams of NH3. So nitrogen is like, what, 14? 14. 15, 16, 17 grams. Moles of NH3. What am I thinking? Hold on. I'm just like messing around with my tabs. we go moles, mole ratio, NH3. There we go, moles of NH3. So we have 4 moles of NH3. What am I on? H3. I'm just gonna pick the NO, nitrogen oxide, because it's easier. So it's gonna be a 4 to 4. So I don't really pay attention to that. Well, it's not that I don't pay attention to that, I still kind of need that. 2 moles. NO, just nitrogen oxide, into grams of nitrogen oxide. 14 plus 15.9 is 29.9. What am I doing? Right. So that's that. So 3.50 grams of O2. Let's try this again. So we get moles of O2, grams of O2. This can be 15.9 times 2, 31.8. Maybe 5 to 4. Moles of NO, moles of O2, times 29.9 grams of nitrogen oxide. Okay, so that's that. Let's go ahead and crack this down. Boom, boom, boom. Divided by 17 times 29.9. This gives me 5.71. 2 grams. 3.5 divided by 31.8. Is that a 0.8? That's a 0.8, yeah. Can make that a lot more clear, that's the point. Uh, 31.8 times 4 over 5 times 22.9. That gets me 2.01. 2.02. There we go. So our limiting reagent is the oxygen. And we get 2.02 grams of nitrogen oxide. How much of the excess is left over? So, okay, so like, I think it's 3.5 minus 2.02 gives me 1.48 grams. What would the percent yield be if you did the reaction above and produced 2.25 grams? So that's, okay. Actual over theoretical times 100. So our actual is 2.25. Our theoretical is 2.02 times 100. 2.25 divided by 2.02 times 100. Wait a second. .25 grams of nitrogen oxide is produced . 2.25 over 2.02 times 100. Okay, just 111%. Yeah. And that's it. 111.4. We'll go with that. Anyways, So I'm just going to zoom out. I'm going to I'm going to copy down my work back to my paper. So that's 3.25 grams of nitrogen. Look at that. Moles of it. I think it's ammonia. 17 grams of times 4/4 moles of NO, moles of NH3 times 29.9 grams of 5.72, 3.5 grams of, hold on, 3.50 grams of O2, 31.8 grams of O2, moles of O2, times 4 moles of nitrogen oxide, 5 moles of O2, times 29.9 moles of nitrogen oxide, 2.02 grams. Okay, so that's all my work copied down, and I'm done with my chemistry homework. So let's go ahead and squish all this down. Okay, I'm done. So that's all my scribblings for today. Let's go ahead and clear up my calculator. Okay, we're done. Time to game on that. Nah, man, I'm going to sleep. I'm tired, man. Well, I finally completed my chemistry homework. It only took me like, what, 2 hours? Not bad. Yeah, so yeah, that's gonna be it. Oh boy, okay, so as usual, thanks to everyone who's currently watching for sticking around to the end. And VOD gang, if you're watching for whatever freaking reason, see you later, man. Yeah, but catch you later. But yeah, like, VOD gang, if you're still here for whatever reason, thanks for watching, and don't forget to like and subscribe. I just want to go to sleep now. I'm just gonna